today. Let's fill her in. The warm-up, what was the goal? What's in yellow? What was our key tool to solving for x yesterday in the warm-up? Yeah, the radical. The radical is the key, because what does a radical undo? The square root. Not the square root. Radical square root is the same thing, but how do you word it? You have it in your head. No, what does the radical undo?
2, the second power.
Square. Yeah, not square root, just square. Okay, so radical undoes squared. So we're trying to get the squared guy by himself. Now, some of you, and I can tell from the people that came in after school yesterday, some of you need to be doing things like drawing boxes for yourselves. It makes it so much easier sometimes, meaning, who's the squared guy in letter A? He's right there. So I needed to get him by himself. How do I do that? Subtract the 20, divide the 5, which is what we did. But who's the squared guy in letter B? The squared guy in letter A was this one, and we needed to get him by himself to put the square root in. Who's the, this whole thing is the squared guy. Now 25 is a perfect square, and 9 is a perfect square, but who has the squared written? Is x minus 2 squared. So we needed to get this alone so that we could square root that square. So the object is the exact same, even though the problems are a little bit different. Get the squared guy by himself so we can finally undo the squared. Get the squared guy by himself so we can undo the squared with a radical. And anyway, that was review, but undoing squares with radicals. At the very end of class yesterday, though, we saw something had changed. This was the second thing that you guys were supposed to get on your paper yesterday. It's the example right underneath the big box guy on the left. What's different? Who do we have now? There's kind of an exponent. Yeah, I was just thinking a square root. We don't have squares in there anymore. Now we have a square root. So Alexis, this is what you were supposed to have yesterday. You're getting caught up on today. Let's get that English essay put away. So the square root is who we have to get alone. So we add the 7, we got the square root alone. And guys, if a square root undoes a square, what did you see yesterday undoes a square root? Yeah, you go the other direction. This would undo that. Sweet. Or I should say, this would undo that. Then we can use the squared to undo the radical, the same way we use the radical to undo the squared. So for those of you guys that take notes, it might be helpful to put into words what we're doing. We're getting the radical term, the guy with the square root. We're getting the radical term alone. And then we eliminate the radical using exponents. Now, that's technically what you always do. And this is leaving room for things like a cubed root. We're going to use a cube. Or a fourth root, we're going to use a fourth power. But if you don't see anything inside the radical, guys, what's the understood radical when there's nothing in there? Yeah, understood 2. And we never write it because we just say, oh, like an understood 1 in front of x. An understood root or radical is going to be a squared. Because there's no purpose to have a first root because it doesn't mean anything. Because you have to have pairs of 1. That's awkward. It's not even a pair. But pairs of 2, oh, that makes sense. Or groups of 3 or 4 or 5. Anyway. The most basic radical is a square root, so we need the squared to undo. If we had a cube root, we would just need a cube to undo. If we had a fourth root, we would need a fourth power. That's kind of what the words are saying. But in our context, we're going to have square roots, and we just have to undo them with squares. Now, yesterday, when we were doing this, the one weird thing is that I didn't slow it down. I didn't go to absolute value. Because this square root, you kind of see it here for anyone who was gone or kind of didn't pay attention at the end of yesterday. If there's nothing in front, it's a positive 1. Since it's a positive, I actually know at the end of the day, when I square a positive, when I square a negative, I'm going to end up with that positive answer. And I'm good, and I'm done, and I don't need to put more than 1. I'm just looking for 1 answer, not for 2. That's a little different than quadratics, which might confuse a few of you. But the nice thing is, if you have a square root and you are squaring it, if you have a square root and you're squaring it, you don't have to worry about the absolute value. You don't have to worry about the absolute value. Another way of thinking about that is that if you read this statement, the square root of who is 10? Well, you guys, some of you have the square root so memorized, so think about it. The square root of who or what would make 10. 1, nope, that's 1. 4, nope, that's 2. 9, nope, that's 3. What square root, what would I need under there to make a 10? 100. Wait, what if it was negative 100? Can I have a negative underneath the square root? No. That's another way of thinking about it. Only a positive 100 will make this statement true. Only a positive 100 should be going under that square root to make that 10. So all that to say, don't worry about absolute values. Don't worry about slowing down. This time we're only looking for the positive answers. So guys, we had some examples we didn't get to finish yesterday. I'm going to open the door because I don't know about you. Coffee mornings is always warm in here. I want you guys to at least try number 1, but maybe the others. But what I want you to do first, especially for those of you that are more visual, I want you to go through and find the radical in each of these. Go find the radical in each of these, and then you need to think about, I need to get the radical alone. Move everything else legally away. Get the radical alone, because only when I have the radical alone on one side of the equation with everything else on the other side, only then am I allowed to square. Only then am I allowed to square. Ready, set, get the radical alone, square both sides, see if you can finish. And if that first one makes sense, try number 2. Maybe even number 3. I'm going to catch up with you guys as soon as I open up the door. Okay, let's get the air coming in, huh? You guys getting the radical alone? Let's kind of try. So Andrew's gone. Max is gone. Brooke is gone. Oh no. Andrew Bosch, what's up?
So I'm confused on number 2 because I already did it, but then
I'm drawing random lines. Okay, so we have a little discrepancy on number 2. Let's double check number 1 first and make sure all the steps were good. Then let's switch them. So number 1. Number 1. Sunny, what's the first thing that you did? Got him. So 5 is equal to square root of x. Everybody, is my radical alone? So Melanie, what'd you do next? Good. So square both sides. Once that radical is alone. I'm going to go ahead and move this up to the top because this is kind of like our goal of what we always want to be doing in radical equations is getting the radical alone so we can square. And remember, everybody, the point of squaring the radical is undoing it, right? The point of squaring the square root is undoing it and getting to what's underneath. So when Melanie said square both sides, she was perfectly correct, and the purpose of that was to get to the x. What's 5 times 5? 5 squared. And we wouldn't write it normally like that, right? We would use that whole commutative property to rearrange it, but yeah, that's good. Give me a thumbs up if you're like, I got to 25 before you did. Nice, 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 nice. Anybody who didn't get there first? Any questions on number 1? Oh, we bring it in, yeah. So the x was trapped under a square root, so we come at the square root with our mathematical tools of being like, I know what undoes you, a squared undoes you. So the inverse operation of square root is squared. The same way that, ready, everybody? Subtraction has an inverse that we bring in. The plus 3 was not there anywhere to begin with, but you know from your prior training in pre-algebra and algebra 1 to add 3. Why? Because it undoes the subtraction and gets it away from the x. That's exactly what I have to do with the square root. But I can't use addition. I can't use subtraction, multiplication, or division. I have to use an exponent, and not just any exponent. I have to use whatever type of radical, whatever type of root, that power to undo it. So Armando, does that make sense? I'm bringing in the squared to get rid of the square root. Cool. So then over here, Andrew, you were saying you and Levi had a little bit of discrepancy. What was the first step that you did in this problem, Andrew?
I did I minus 5.
Okay, totally valid. Totally valid to minus the 5, to subtract the 5. And it was important that you subtract the 5 because, guys, a lot of you see this minus and you get confused. This subtraction, does it make the 5 negative or the square root of n negative? Yeah. It says subtract this guy. So the 5 was an understood positive, so I have to subtract to get rid of them, 5 minus 5. But wait, algebra says what I do to one side, do to the other. For those of you that negatives are confusing, remember 2 minus 5. Yeah, I subtract the 2 and keep the sign of the stronger guy. He wins the battle. But when they clash, they take away from each other. 5 minus 2 is 3. I keep that negative. Now, hold on, Andrew. Would you write still over here on the left?
I wrote the negative with the radical.
Good. Is the radical technically alone yet? No. So how do I get rid of the negative that's in front? Subtract. I like divide. Because, yes. You could technically multiply by a negative. You could multiply by a negative 1, because, guys, what's a negative times a negative? Okay, that's one way. So I could multiply both of them by a negative 1, totally legal. I could have divided both by a negative 1. Or there is that weird, crazy idea that actually might be easier from some of you. Can I show you the alternate way? Or you could have had that negative root n is equal to negative 3. You could have added this guy over here, and then you could have added the 3 over here. You could have actually just rearranged them and gotten the same thing. So if you are thinking of adding, that's not totally bad. Just think, okay, if I add this one, I should add the other, or I should move the other one also. That is a way of doing it. It's just kind of creative and takes more steps, so most math teachers don't really show that way. And you can think of this as being a negative 1 times, so then you can undo with division or multiplication of a negative. But at the end of the day, you end up with square root of n equals what? Positive 3. Right? Well, I heard, maybe it wasn't you said divide. Somebody yesterday said multiply, and they were totally correct in that it works. So I was just kind of doing what I did after school with somebody. I think it was might have been Armando. But when we divide, it would have worked the same way, Kayla, and it might have made a little more sense. Because there is a negative 1, and when you divide by a negative 1, it'll go away the same way. So yeah, whichever one you're more comfortable with. You can multiply by negative 1, you can divide by negative 1. Negative 1 is the one exception you can multiply or divide. And it should divide negative 3 by the square root. Well, I just did a negative divided by a negative as a positive, and I haven't dealt with the square root quite yet. So that's what I'm going to do next. Because I need to get to n, and the only way to get to n is to get rid of the radical, and the only way to get rid of the radical is to bring in a square. So I'm going to bring in a square, because now it's time. The radical is isolated. He's on his own. He's his most vulnerable, is one way if you want to think about it, like in battle terminology. And so we can take that tool that will undo, and we bring in that square and say, you're gone. Well, now he's gone. When the radical goes away with the squared, what do I have left, Jeremy? N, good. N is left, and then what's on the other side? 3 times 3. Okay. If you haven't tackled number 3 yet, I'm going to pause, and you guys go tackle it. Some of you already have. Perfect. No big deal. Go to number 4. It just got a little bit harder. If you haven't gotten to number 3 yet, let's just give everyone a chance to tackle it on their own. totally by himself first, so that he's the only thing there. Even negatives get those to the other side. Then so it's just safe. You're gonna feel the space that way. Yeah. And where I was showing him was actually music. Number 3? I see it. I see it. Who else has number 3? Oh, still thinking. Oh, still thinking. Keep going, Joseph. Oh, so divide by the negative first. She has number 3 done, so does Adrian. You don't. You have it right there. Okay, I see at least I only made it halfway around the room, but I saw a lot of people getting it right. Gave a couple hints, a couple tips. Did most of you subtract the 4 first? And you do that to get rid of the 4, right? And then you should have gotten negative 10 is equal to negative radical y. Now, okay, you can technically square both sides right now, but it's super dangerous because a lot of you would not get rid of the negatives, even though squaring a negative is a positive. So please don't square yet. Get the radical totally alone first. How do I get rid of negatives? You can either add, or you can multiply by a negative, or you can divide by a negative. Positive 10 is equal to square root of y, and as soon as we get that radical isolated, the time to attack is now, and how do I attack the radical? Squaring. That is what will be his undoing. So when I square, I saw a lot of people with the right answer of, got him. But who started peeking at 4, 5, and 6 and saw it got a little bit harder? Now pause. Look at the warm-up from yesterday. Doesn't letter A, and you might not see it, but if you do, man, math is full of patterns, and if you see the patterns, you can learn from those patterns. Do you see how in letter A, the x squared was kind of all close and tight right here? I just had to get rid of everything, and then it was like, hey, square root, and you're done. Well, square root of a negative didn't work, but we would have been done if it had worked. Wasn't B a little bit harder because there was like a minus or a plus or something inside the square? Yeah. Look at number 4. Is there now something minus or plus inside the radical? You see it? It's kind of similar. It really is. But just like this, use the same technique. So will number 4. It's not crazy. It's not out there. Let's see if we can make sense of it. Ready? You're still trying to get your radical by itself. Whatever is underneath it, you're still trying to get it by itself so that you can say, ha, I'm undoing you. And what you do to one side, you do to the other side. That sounds sinister. Sorry, I didn't mean to sound sinister. But undoing the square root. So pause. Can you please put a box around your radical in number 4? Where's the radical? The whole thing. You see it? I need to get that alone to bring in the square to undo the radical. So, okay, what's the one thing I need to do in number 4? First, yeah. Plus 8, plus 8. I'm still just getting my radical alone, even though there are harder things underneath it. No big deal, I'm getting it alone. Radical, the whole thing, n minus 4, is equal to, mental?
5.
What can I do once I have the radical alone? Careful the wording. Square, just square. The root is the radical. You don't want to do another root, that'd be bad. It's like doubly tracked. And I swear. The only thing that's different is I'm not totally done once I square, but guys, you've just freed the n minus 4. How did I free it? Well, because the squared undoes the radical. I get n minus 4 is equal to, careful, 5 times 5. Remember what squaring does, right? 5 times 5 is 25. That's easy now. All you gotta do is. So go try number 5, if that made sense. If that didn't, ask me a question.
Oh, I got that.
Yes. Here. If you have all 3 of them done, check it with someone else that has all 3 done. See if you have the same answers. If not, look at the steps. Do all 3 then, 4, 5, 6.
I was trying to make it wrong.
You do only divide it. You don't subtract. There we go.
Oh, I know.
Are you like done? Isaiah, check in on Everest real quick. Make sure he's doing it okay. You good? Division. So you had the right idea. Like it was the perfect idea. Finish it and then careful.
Always divide it by 7.
Alright, hold on. I see a lot of you that have you started, some of you finished. Where was your radical? Okay, hold on. There are multiple of your classmates, and it's a common mistake that tried to get rid of the 7 by subtracting. Can you explain why subtracting couldn't get rid of the 7? It's next to, and what does next to mean in algebra? Multiplication, so how do I get rid of it? Division, good. So a lot of people had the right idea, they just maybe didn't really understand or didn't slow down to see the times. So divide by the 7 goes away. Ha ha! I have my square root by himself, isolated, ready to go. 14 divided by 7 was 2. And then what did you guys bring in? It was prime time to? Yeah? Square root squared. The x plus 6 was finally 3. 2 squared is? And then hopefully you guys subtracted 6 to end up with x is is equal to.
That's good.
Who beat me? Give me a thumbs up. Okay. Are we good? Okay. So the biggest mistake that I saw of the people that were working on it was just knowing what to do, just accidentally subtracting instead of dividing. No big deal. No big deal. Just slow down and be 7 times. Oh, I gotta divide multiplication. Otherwise, pretty good. How many of you guys kept going to number 6? I'm gonna go slow. I'm gonna give you 30-second handicap just in case you didn't go to number 6 yet. Get that radical alone. So Brooke, what we're doing is we're seeing the harder ones from yesterday. We're remembering that the way to undo a radical is with a square. Kind of like how subtraction, you add and it goes away. What's harder is you just get this guy. Then swap. Now he's free. Second one. 5 more seconds.
No, what you do first?
Oh, it's gonna get all the self-loaded to the graph.
Huh? What did?
It's gonna be a self-loaded to the graph.
Oh, yeah. Because, the underneath just looks a little bit harder. I think that's why it was at the end, because it had like a 9. You guys added 1, yeah? What's it time to do?
The square.
Get rid of the square root with a, yeah. Watch out for that vocab. So if you say square root, people are like writing radicals, and that's bad. But squared, got him. What does that squared do? Frees up the 6 times 6? Now it's just algebra, right? Subtract them. Now for some people the mental math is a little bit rough when you're subtracting 36 from 9 or 9 from 36. I think about powers of 9 because 36 is a power of 9. What's the one right before 36? 27. But some of you guys might have actually subtracted either in your heads or with your fingers, either way. And then divide by 9. Who beat me to 3? Give me a thumbs up. Some of you, I see you still working. I probably just didn't give you quite enough time so you can start on it. Now guys, where are we in context of our worksheet? Flip it. The next side is B, and guess what tomorrow is? Oh, sorry. The next side is B. Today was finishing A. So we actually got through A. I want you guys to go ahead and, hold on, before we go away from this, we might look a little bit at B, just for 2 minutes. But before we totally go away from A, you guys write down the homework. And if you want to, get out your homework spiral. You're going to have at least 10 minutes to work on homework. I have the book open. I'm going to put it on the screen, but we're going to peek at B just for a little bit first. Because what made today so easy is that we already started. You guys notice that? Like we already kind of started. We jumped into examples. We're going to peek at B just a little bit. So tomorrow is easy too, so we can jump into it. You guys will have at least 10 minutes to do homework. And I'm going to put it on the screen. Yeah. The quiz on Friday is on 10.3a and also 10.1 and also 10.1. We didn't have a quiz on it. Yeah. It was last night's homework and I didn't have it due until tomorrow. I changed RunWeb. You might have looked at it before I changed RunWeb. So yeah, some of you are already done with this homework. So if you start on B and if it makes sense, we can already get started on the next homework. Jerry. Yeah, zoom. Okay. Couple more seconds in case you're writing this down. You're going to have at least 10 minutes to work on this, which some of you realize these might go fast. Maybe you can get a little faster. But we're going to peek at 10.3b just for a second. So about 5 more seconds to get this written down. And I'll get the page ready on the whiteboard. Oh, I had the wrong section open. That doesn't help you at all. Okay, now I want you to go over to part B just for a little bit. Remember, we're just introducing part B. Let's skip the warm-up for now. I think the warm-up would be a good one for tomorrow. And let's just peek at this graphing thing. Let's just peek at the graphing thing just to start. start 10.3b. We'll come back, we'll jump into it tomorrow, and we'll hopefully, once again, finish notes and finish worksheets early so that you guys can work on homework. But I want you to take a second, just before we totally transition to homework. Look at what I've drawn or what I've written on the board for these two problems. Is that something that would help you if you wrote it down in your directions? I think so. Read the directions. It says, use the graph to solve the equation. The directions say, use the graph to solve the equation. But guys, what do I put right above there? What's my hint? How do you use the graph? Look for... Write that down in your worksheet. It's going to be helpful. Remember, these worksheets help us a lot when it comes to homework. Use the graph means look for the intersections. If I'm trying to know, some of you might realize maybe these are hard, maybe they're easy. We see radicals all over the place. If nothing else, they're at least a little bit more advanced than the ones we just did. But I'm not even asking you to solve it. I'm just asking you guys to look at. I'm just asking you guys to look at 1 and 2 and just look at the graphs and use the graphs to solve. Oh. I'm going to wait for your notes and went into the homework. Oops. Now you're in calculus all of a sudden. Okay, back to algebra. That was scary. Where's the intersection for this guy? Right? Like 2 and 1.75 maybe? I don't know. If you guys look at your graph, it's 2 and something. But wait a minute, hold on. Who's the only variable that's in the beginning part? X or Y? Oh, so I'm not even caring about the Y value. What I want to answer this question is which X will make this true? And the X that will make it true is the same thing as the X of the intersection. So, I mean, the X is very clearly what? How could you double check that it works? What happens if you plug in 2? 2 times 2 is 4, minus 1 is? How about 5 times 2 is 10? 10 minus 7 is? They're both square root of 3. Yeah, 2 is the right answer. And it was as easy as finding the intersection on the graph and saying, I'm only looking for the X. So you guys, your turn. Number 2. What is the solution, the X solution for this equation using this graph? X equals? Yeah, but louder. -1. X equals -1. Why? Because they come together and intersect at, well, okay, this point is what? -1, 0? But I don't care about the Y. He wasn't even there to begin with. All that was there to begin with was the X. So I can just look at it and say, X equals -1. Now, do you guys want to just see a peek at what's coming? We have 1 more minute until we go to the homework. What's coming is not just using graphs to solve, but using our algebra skills to solve. Question. Are these radicals by themselves on each side? On this side, is this radical alone? Is there anything else outside? Addition, subtraction, multiplication? No. How about this guy? Addition, subtraction, multiplication? No. The same way that we can bring in a radical when there's one radical alone, we can bring in, sorry, did I say the radical? The same way we can bring in a squared when the radical is alone on one side, we can bring in a squared when the radicals are alone on both sides. What's going to happen to both radicals if we were to not use the graph but solve with our equation skills? That radical would disappear and that radical would disappear. And when both of those radicals disappear, what would end up happening? Well, what would be left, guys? What's left on the left side? 2x minus 1. What's left on the right side? 5x minus 7. Is that something we should be able to solve? Yeah. Can't we do a minus 2x and a minus 2x? And a plus 7 and a plus 7? You know what's really cool? I don't think we need graphs to be able to solve this. What do you think? If I can get a radical alone on both sides, I can still use the square tool to come in, to undo the radicals, get x equals 2 without even knowing the crazy graphs. And for some of you, you're like, yeah, I don't like graphs, so that's a good thing. Hey, check out the rest of the examples on that page. Does it look kind of like we just did? Nice. All right, pause. Pause. We don't have to go all that far today. Let's get back into homework. Homework was 3 through 9, 13, 15 through 19. 3 through 9, 13, where's he? There we go. And 15 through 19. Does this look a little bit like what you just did on your worksheet? The answer is yes. Ready, set, go. 10 minutes. You need a lot of this done. Don't worry, worksheet, we'll be back to you tomorrow. Even though you guys are doing awesome, it's just harder than tonight's homework's going to be. Pause, slow down, bust out this homework. You guys are awesome. 10 minutes. You need to zoom in a little bit more, or can you see it? You guys can see it okay? I can zoom in, I think. If you didn't write down the homework yet, it's over here on the sideboard, all nice and circled. The name of the game is solve. How to solve? Get that radical alone and square. In your homework spiral, you can leave a separate paper. Get that radical alone. Got it. Andrew, extraneous ones are the ones where you plug in and try and it doesn't work. We'll see tomorrow as to where they come from. They're kind of confusing. I would do just a couple so it cements it in your head to be like, I know what I'm doing. And then it's good for tonight so you can look at it. Yeah, this is the 10-1A, I think, right, Andrew? Oh, you're missing 19 and 20. Did you put it on your worksheet? No. There were 2 graphs at the very end. And you might have put it in. And then, Jonathan, you were the one that showed me homework at the beginning, right?
Yeah.
Got it. Thanks. And then, Hannah, do you have any 10.1 homework? We graded it yesterday. We're looking for 10.1A and B. It was page 548. It's back here. 548. Yeah. 5 through 20, and then like a 22, 24. And there was also the worksheets, the 10.1A, B, and intro.
Let me check the work.
Okay. Ooh, big key. Good comparison. Got it.
Yeah, that's true. You're right. They're not gonna have anything else with the phone on them. Yeah.
Andreas, here you go, Ben. I wrote down the time. It's not 1, so it's 5 through 20. So you can see. And then don't worry, we didn't graph those either. We just cited the tables. So you have that. Okay, do you have the, there was one more, chapter 10 intro. It was like an 11. I think you have it. Okay. So Hannah's showing me Max is still gone today, and Andrew's still gone. And then Brooke, you Alright guys, you still have a good 5 minutes, so use them well. Keep tackling this homework. If you can get a few done right now, if you can look at them tonight, you'll be able to pick up right where you left off. Just kind of like today in class, when we were able to pick up where we left off, it was so much easier. That's what you're doing for your homework right now, starting it, and you can pick up where you leave off later. You guys feeling good? You rocking it? Good. That's the goal. Save that for tomorrow. We'll talk about it. He does the pictures. Well, did you already subtract the 7 and divide by 2? The radical tracks this guy. So he's totally his own dude, right? So you're just looking at these two. And whenever we solve an equation, we actually go backwards. So like in this one, didn't we always add or subtract first? So like here's an easier one, it's not as hard. We would have added 18 because we reversed the time down. So we do the add subtract first, then we undo the multiply divide, then we undo the power. Because you would subtract 7 from 8 divided by 6. Yeah. So you're thinking 10 times correctly, but when you solve to the other side, Adrian, we're actually going backwards. Does anybody else have any missing work or late work? Since we had a little extra time today, I got a few of your scores down. Alright guys, keep this worksheet close, but you also have a really good start on homework. If you're not done, you at least started it. Like, keep going tonight, finish it, rock it, have it ready for tomorrow. For us to grade and check and go over questions. Alright, Brooke, if you want to come grab it, I'll give it right back. So give you full
Okay.
credit. Alright, bye guys, see you later. Excellent work today. We'll jump in tomorrow and just keep going. Life's so much easier without those graphs.